All right, ladies and gentlemen, we're going to get started here with Chapter 9. Chapter 9 is entitled Nomenclature, and it's a really long word that has a really simple meaning. The simple meaning is that we're just going to learn how to name chemical compounds. That's our job. In fact, we've already started a little bit of this. If you remember back in Chapter 7, we were learning about ions. And you had an ions list that you had to memorize. In fact, we had a special quiz just on the ions from the ions list. That hasn't gone away. So if that is something that has sort of left your brain over the last several weeks, you need to start looking back over it, because it is something that we will be using quite often, not only in this chapter, but for the rest of the semester. Okay, so that's something important for you to keep up with, is the idea that you need to know those ions. There will be even parts of the video to come here, the notes to come, where I might even mention that you don't have to memorize the ions, but it was for a different class. So ignore that part. You do have to memorize the ions, okay? So anytime that we talk about the ions in any of these slides coming up, these are on an ions list that you should already have back from Chapter 7. And you will need to know them, because when it comes time for the test, you will not be able to use anything but, again, just a regular old periodic table, which does not have all of the names and charges of all of the ions you need to know. Okay? So in this chapter, we're going to learn how to name more than just ions, right? We're going to learn, we're going to go back through and talk about the ions a little bit. We're going to talk about how to then put ions together to name ionic compounds. We're going to review a little bit about writing formulas for compounds also. But we're also going to go a little bit further. One thing that we never talked about back in Chapter 7, since Chapter 7 was all about ionic compounds, we never talked about how to name molecular compounds. Right? Covalent. Well, that was from Chapter 8, and we really didn't have any time in Chapter 8 to talk about naming. So we're going to do a little bit of that. We're also going to talk about how to name acids and bases, since those are things that we do use commonly in chemistry, and we're going to need to know a little bit about how to name them and write formulas for them. And then finally, we're going to talk a little bit about some of the scientific laws that govern the formulas that we're talking, these chemical formulas that we're talking about, right? Why are chemical formulas the way they are? There's a couple of different laws that explain that, okay? So again, here in Chapter 9, right, we're going to go through how to name compounds. The first thing we're going to talk about here is naming ions and ionic compounds. Please make sure you realize you need to still memorize the ions. That is not a list that you will be able to use on your tests. So part of doing chemistry is obviously being able to call things by the correct name. And there is a system to how you name things in chemistry. Okay? So we use something called nomenclature. Anytime you learn nomenclature, you're learning a system of naming something. Okay, and there is definitely a system of how to name chemical compounds, because we can't just have people naming them whatever they want to, right? Like, there's no nomenclature to naming children, because your parents can, for the most part, name you whatever they want to. Okay, and if and when you have kids, you can name them almost anything you want to. But we can't have that for chemical compounds, because chemical compounds are things that multiple scientists around the world may be using, developing, discovering. And we need a system where everybody's going to name it the same way. Okay? We're going to start by naming ionic compounds. So again, ionic compounds would be metal, non-metal, right? There are two ions, a positive, a cation, and a negative, an anion. The basic organization that sets up all of these rules that we learn is called the IUPAC. It's the International Union of Pure and Applied Chemistry, and it's basically chemists from all over the world that come together and they make up a set of rules that everyone around the world follows in terms of naming the compounds. Okay? So for ionic compounds, every ionic compound has two names. You always start with the cation, that's the positive name, and then you end with the name of the anion, the negative. Right, so there's always two names. It is pretty easy because it only has two names. The only hard part is you have to learn how to name the cations and the anions. So we're going to go through how to name the cations and the anions. And then I'm going to give you some hints as to how we're going to make this easy. Okay, because we're going to make this relatively easy for everybody in here. Let's start with the cations, because remember, those are always the ones that come first in an ionic compound. Cations, which are the positive ions, can either be one atom, monatomic, right? Mono means one, so they could be monatomic, or they could be polyatomic. Poly means many. So the ones that are made up of just one element, those can be either the kind of element that has just one possible charge, or the kind of elements that have more than one possible charge. Now, how do we know charges? Well, remember, we learned a pattern on the periodic table, right? We learned that if you're in group 1, that means you're probably going to be a positive 1 ion. If you're in group 2, you're a positive 2 ion. If you're in group 13, you're a positive 3 ion. So we know that there are certain groups on the periodic table that always have the same charge. And those are really, really easy to name. You simply just take the name of that element. That's it. So if you're talking about Na positive is a sodium ion. You don't have to do anything to the name. Na is sodium, so that's just called a sodium ion. Mg positive 2, that's just called a magnesium ion. We don't have to do anything special to it because those are elements that are in groups where we know what the charges are. Nobody needs to tell you in the name that sodium is positive 1 because everybody could look up sodium on the periodic table and they could tell that it's positive 1 because it's in group 1. So that's why for any of the metals that are in group 1 or in group 2 or in group 13, we just use the name of that element and that's it. We don't have to do anything special to it. But what if it's one of the other metals? Like what about all those metals that are in the transition metals in the middle of the periodic table? Those do not have a simple pattern of charges. In fact, many of those elements that are in the middle there, many of those metals have more than one charge they could be. For example, as you can see in this example here, iron has two different charges that it comes in. It could be iron positive 2 or iron positive 3. And that means that I can't just say iron ion, because then most people would be like, well, which one are you talking about? Right? Because there's two of them. In those cases, we have to use a Roman numeral after the name of the metal to describe how many positive it is. So Fe positive 2 would be iron Roman numeral 2, or Fe positive 3 would be iron Roman numeral number 3. Copper is the same way. Copper comes in a positive 1 version and a positive 2 version. So depending on which one we're talking about, we have to use the correct Roman numeral with it. Don't worry about this older way of naming, right? We're not going to use that in here. So out of all the metals on the periodic table, it's either going to be a metal that's in group 1 or 2 or 13, in which it follows the rule where we just name the element. We don't have to worry about any Roman numerals. Or it's one of the metals that are in the middle of the periodic table, and we don't know which one it is, and so we have to tell somebody with the name what the charge is. Now, polyatomic. right? Polyatomic cations means there's more than one element that together as a group has a charge, right? For example, there is a group that is listed as NH4, so it's a nitrogen and 4 hydrogens. A nitrogen and 4 hydrogens all got together, and they have a positive 1 charge. That ion, that whole group, is called ammonium. You're not going to find it on the periodic table. There isn't an element ammonium because this is more than one element. This is a group of elements together. So they have their own special name. Now the good thing about these polyatomic cations is since you can't find their name on the periodic table, I'm going to provide to you a list that has all of the ions on it. All of the polyatomic ions. Okay, so these are all the different cations that might exist in an ionic formula. Let's talk about anions. For anions, we also could have a monatomic anion, just made out of one element, or we could have an anion that's made out of multiple elements, polyatomic. Now, it turns out there's a lot of polyatomic anions that exist out there. There's just a few monatomics. So we'll cover monatomic first. Remember, monatomic just means one element. Since we're talking about anions, anions are always nonmetals. So remember where the nonmetals are on the periodic table? They're over on the right side of the periodic table. Those are where the nonmetals are. That would be things like oxygen and nitrogen and phosphorus and sulfur and chlorine and fluorine and bromine, neon and krypton and xenon and all those. All of those over there on the right side of the periodic table. So if you have one of those elements, one of those nonmetals with as an ion, the one thing you have to do to the name of that element is you have to change the ending to "ide." So if you were talking about H negative, for instance, you wouldn't call that hydrogen, you would call it hydride. If you were calling F negative, you wouldn't call it fluorine, you call it fluoride. O negative 2 is not oxygen, it's oxide. So that's the one thing we have to remember. If it's the negative anion, and it's just one element from the periodic table, one nonmetal, we have to change the ending to "ide." For the polyatomic ions, remember I said I'm going to provide to you a list of them. Now I'm going to show you just a couple of examples of them and some things that I want you to remember about them. Let's start with polyatomic anions that have oxygen in them as one of the elements in the group, like ClO with a negative charge, or ClO2 with a negative 1 charge, or ClO3 with a negative 1 charge, or SO3 with a negative 2 charge, or so on and so forth. There's a lot of them, and you'll see more of them on the list that I give you. You'll notice that all of them that have oxygen in them always end with "ate" or "ite." So anytime you see an ending on a name that says "ate" or "ite," you're talking about having oxygen as part of that group. But you don't have to memorize all of these. You can look them up, so that'll be useful too. There are other polyatomic anions out there that don't necessarily always end in "ate" or "ite. So just because it has "ate" or "ite in it means it has oxygen, but it doesn't mean it's the only time. And then sometimes it's going to have hydrogen and oxygen. And in those cases, a lot of times, you'll see the word hydrogen in front of another name. Right? So you might have hydrogen carbonate or hydrogen sulfate if there's an H along with the rest of the ion. Okay? But again, all of these that you see as examples on here, they're all going to be on a list that I will provide to you.